moment I'm going to switch it on, you can see what happens when water flows over the weir. And the experiment itself is quite simple. All it is can we relate the flow rate over the weir to the height of water upstream of it? So you'll see what happens when water goes over the weir. A funny thing happens in terms of the water levels as the water flows over the weir. And what we're interested in is the water level upstream and the flow rate. And those two things can be related together using a weir, the so-called weir equation, which is very common in civil engineering hydraulics. We just pan the camera around a bit. Hopefully I can do this without too much trouble. There you are. You can see the flume. It's quite a long thing, goes right down the end of the lab like that. And then I go the other way as well, past me, and you can see we've got you see the sort of orange tank at the end there. This thing. So that is the header or the tank, which supplies the water at one end. And in fact, if we go down, I'll just lift this. Hopefully, you can see it if I go down a bit. There we go. You can see down here is actually the pump mechanism. So you can sort of see there's a pump down there. This is the pump, the hefty great thing, the pump and the pipe work. Okay, so I'm going to turn it on now, and so what you'll see, hopefully, is water flowing over it. And I just want you to see how the flow changes as I increase the flow rate. So first of all, you'll hear a sort of a gurgling noise, and then as the flow increases, so the water level increases, and then gradually you'll see what happens to the water level either side. So. So first of all, that's a fairly low flow rate of about 19 litres per second. 19 litres per second, and what you can see is that we've got a water level here, which is constant. So we've got steady flow here. And as I turn the camera around, you can see what happens. Firstly, upstream, that's the upstream side. And then downstream. And so, you can, in a sense, see, if I sort of zoom in a bit on that, you get a sense of what happens as the water passes over the weir. That's at 19 litres per second. So what I'm going to do now is increase the flow. that's about 25 litres per second. I hope you could see when I did that the water level upstream here, this went up, this increased, as you might expect. We've got more water to flow over the weir. So the interesting question is, well, how can we relate that water level to the flow rate that we've got here? Also, one of the things that you'll do at some point later on in the module is that you'll talk about different types of flow. This is all open channel flow, and so I hope you can see a difference in the flow regime between upstream that side and downstream that side. So as I go round, there's the upstream, nice and smooth flow, no particular sort of turbulent issues there. Whereas down the bottom we've got actually much rougher flow, much faster moving flow, much rougher surface. And we make a distinction in civil engineering between two types of flow in open channels. One is subcritical, the other is supercritical. So try and remember that. That's a key difference in terminology. So when you come across the theory, you'll be able to visualize what we mean by subcritical, that's upstream that way, and supercritical, which is downstream. And then as I pan in again to this condition, so you can see the details of what's going on over the weir, can you also see that this water level decreases here before going over? So there's something like a decrease and then a more or less horizontal bit and then another decrease. This horizontal bit we actually refer to as critical depth. There's a special name, it's called the critical depth, and you can calculate what that is, and it turns out that's very important in the design of channels, the critical depth. Okay, so the last thing I'm going to do is now increase the flow rate here to maximum, which is about 32 litres per second. So we had 19, now we've got 25. Watch what happens as I increase the flow rate to 32 litres per second. Actually, because we haven't got any obstructions, we're able to get an even higher flow rate. We're able to get 34 litres per second, which is about the highest we can get on here under these conditions. So 34 litres per second, that's the flow rate, 34. Once again, we've got subcritical flow, critical depth, supercritical. It's the same thing again. I'll just pan around again. So that's the upstream portion, and look what happens further down here. So the object of this experiment really is just to show you what happens when flow goes over a weir, and in a minute, later on, you can do some simple calculations to show the relationship for a so-called broad crested weir like this between flow rate and water level.